Hi, welcome to my channel. Today I'd like to show you how to build a measurement circuit for the strain gauges of an old kitchen scale. The kitchen scale I have used is so-called half-bridge strain gauges. This means that there are two strain gauges in each load cell. Placed in such a way that when the load cell is bent, one strain gauge is compressed and the other is stretched. Thermal effects always affect both strain gauges in the same way, so they are cancelled out. The effect on the resistance of a strain gauge is very small, so it is necessary to use a Wheatstone bridge to measure it. For my circuit I use two of the four strain gauges in the load cell. I connect them in parallel, so that the effect of the load is added up. If load is applied to any of the two cells, the resistance of the positive strain gauges is reduced, while the resistance of the negative gauges increases. This always causes the voltage of the positive output to raise in respect to the voltage of the negative output. Next we need a circuit to amplify the signal. I use an LM358 operational amplifier for that purpose. I measured the resistance of the strain gauges to be around 1K, so the first stage multiplies the voltage by a factor of about 100. This results in a voltage change when putting pressure on the load cells to a few tenths of a volt. The potentiometer of the second stage allows to adjust the output to zero if no pressure is applied. As you can see, the load cell generates a signal proportional to the pressure applied to it. Next, we can connect the output to a microcontroller to read the signal. I use micro blocks to create a small sketch to read the analog voltage, and convert it to a value between 0 and roughly 100. With this in place, we can read the value in any browser. When looking at the values, I saw a lot of noise. I investigated with my oscilloscope and found some small noise on the power rails. Due to the amplification of factor 1000 and the imperfect power supply rejection of the op-amps, this was amplified to an error of more than 1 volt of the output. I quickly tried some filters, but with limited success. Thus if you plan to use this circuit, make sure you have a good, clean power supply. I hope you found this interesting and see you next time.